Hi kids, in this video we'll continue with probability class 10. We were doing exercise 22 and I've done till sum number 16 in my previous video and explained the chapter also. You can click on the I button and get the link. Let's get started with sum number 17, probability. In a single throw of a die, find the probability of getting all these things. First thing, get the sample space. The sample space of this experiment will be, when you throw a dice, you can get 1, 2, 3, 4, 5, 6. And we already know that probability of an event is number of favorable outcome by total number of outcomes by total number of outcome. Now let's just see what they've asked for. Find the probability of getting an odd number. So if you see an odd number, 1, 3 and 5. So number of favorable outcome will be 3 and total outcome is 6, which means the probability will be 1 by 2. Done. Next, a number less than 5, which means 1, 2, 3, 4. There are 4 favorable outcome out of 6. So that's 2 by 3, isn't it? A number greater than 5. So only one favorable outcome, that's 1 by 6. A prime number. Now look, 2 is a prime number, 3 is a prime number and 5 is a prime number. So there are 3 favorable outcomes. Total outcome is 6. So that's 1 by 2. A number less than 8. Now there are 6 favorable outcomes. It has to come less than 8 when you throw a die, which means 6 by 6. That's 1. A number divisible by 3. Now there are 2 numbers which are divisible by 3. 3 as well as 6. So favorable outcome is 2. Total outcome is 6. So 1 by 3. A number between 3 and 5. So between 3 and 6. Between 3 and 6 you have these 2 numbers, isn't it? So your favorable outcome is 2. Total outcome is 6. So that's 1 by 3. A number divisible by 2 or 3, which means 2 qualifies, 3 qualifies, 4 and 6. There are 4 numbers which are divisible by 2 or 3. So 4 out of 6, that's 2 by 3. Done. Whenever you do the sum, write the sample space, if possible. Now let us look at the next sum. Now look at this sum, number 18. A die has 6 faces marked by a given numbers as below. So what you've done, you change the numbers, 1, 2, 3, minus 1, minus 2, minus 3. The die is thrown once. What is the probability of getting a positive integer, which means these 3 integers, which means 3 favorable outcome out of 6 outcomes. So that's 1 by 2. An integer greater than minus 3. So greater than minus 3 are all these 5 integers, which means favorable outcome is 5, total outcome is 6. Always reduce, okay? Now, the smallest integer, clearly minus 3 is the smallest integer, which means 1 favorable outcome out of 6. So 1 by 6. Clear? Now let us look at the next sum. Now look at sum number 19. I'll just read the sum. A game of chance consists of spinning an arrow which comes to rest position at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. You can see the diagram. And these are equally likely outcomes. What is the probability that it will point at number 1? What is the probability that it points at 8? So there is 1 favorable outcome out of 8. So 1 by 8, isn't it? Number 2, let us see. An odd number. So probability of an odd number. Now look, 1, 2, 3, 4 odd numbers are there. So that's 4 by 8. That's 1 by 2. Done. A number greater than 2. Probability of a number greater than 2. So there are 1, 2, 3, 4, 5, 6 favorable outcomes. So that's 6 by 8. That's 3 by 4. Done. Then a number less than 9. See, that's a sure event. Okay. A number less than 9. So if you look carefully, there are 8 favorable outcomes out of 8. So that's 1. It has to occur. Clear? Now let us look at the next sum. Now look at sum number 20. Very interesting. Find the probability that the month of January may have 5 Mondays in a leap year or non-leap year. First thing, how many days January has? Whether you talk about leap year or non-leap year, same. 31 days. Now, in a week you have 7 days. So 31 days means 4 weeks plus 3 days, isn't it? Because 7 4s are 28 plus 3 gives you 31. 4 weeks mean 4 Monday. That's confirmed. Now, out of this 3 days, okay, now you can have an arrangement like this. See, you can have Saturday, Sunday, Monday, or you can have Sunday, Monday, Tuesday, or you can have Monday, Tuesday, Wednesday. So in all the 3 cases, you see, there is a Monday. So 4 Monday plus 1, the 5th Monday, 4 Monday plus 1, the 5th Monday, again 4 Monday plus 1, the 5th Monday. So there are probability will be, number of favorable outcome is 3. In a week you have 7 days. So 3 out of 7. Whether it's a leap year or non-leap year, the answer still remains the same. Because in January there is 31 days. Done. Now look at this. 21. Find the probability that the month of February may have 5 Wednesday in a leap year and a non-leap year. Now over here, we know in a leap year when you talk about, Feb has 29 days, which means it has 4 complete week and 1 day. So this means your 4 Wednesday. 1 day means it has to be a Wednesday so that you get the 5th Wednesday, which means your probability that there will be 5 Wednesday in a leap year is 1 out of 7. Am I clear? But when you talk about a non-leap year, in a non-leap year, Feb has 28 days. So it means it has 7 weeks. 7 weeks means confirmed, 4 weeks, 4 weeks. And 4 weeks means confirmed 4 Wednesday. The 5th Wednesday is not possible, which means the probability will be 0. Done. Very interesting. Now let us look at the next sum. Look at sum number 23. Cards marked with numbers 1, 2, 3, 4 till 20 are well shuffled and a card is drawn at random. What is the probability that the number of the card is a prime number, divisible by 3, a perfect square? It came in icse 2010. Now first of all, when you talk about our prime numbers, so between 1 and 20, the prime numbers are 2, 3, 5, 7, 11, 13, 17 and 19. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 prime numbers out of 20. So the probability will be favorable outcome, that is 8 by 20. That's 4 2 times, 4 5 times. So 2 by 5. Done. Divisible by 3. So your numbers will be 3, 6, 9, 12, 15, 18. So there will be 6 favorable outcome out of 20. 2 3 times, 2 10 times. A perfect square. 1 is a perfect square of 1, 1 is a 1. 4 is a perfect square of 2, 2 2 is a 4. 2 3 is a 9 and 16. So there will be 4 favorable outcome out of 20. That's 1 by 5. Done. Now look at sum number 22. I think we did 23 first, okay? An integer is chosen between 0 and 100. What is the probability that it is it is divisible by 7? Not divisible by 7. First of all, between 0 and 100, there are 99 numbers. So total number of outcomes is 99. That's confirmed. Now from between 0 and 100, the numbers which are divisible by 7 is actually a number multiple of 7, which is 7, 14, 21, like these. So how many? Simple. Just divide, suppose 99, between 0 and 100, the greatest number is 99 by 7. 7 1 times 7, and this is 29, 4 times 28, which means there will be 14 numbers, isn't it, which are multiple of 7, which we can divide easily by 7. So probability will be 14 by 99. Done. Not divisible by 7. Now, divisible by 7 is 14 by 99. So not divisible by 7 will be 1 minus 14 by 99. Isn't it? Which is 99. 99 minus 14. That's 85 by 99. Am I clear or not? Now let us look at the next sum. Now look at 24. A box contains 25 card numbers numbered from 1 to 25. A card is drawn from the box at random. Find the probability that the number on the card is an even number. So when you talk about 1, 2, 3, 4, till 25, there are 12 even numbers, sorry. 2, 4, 6, 2 12s are 24. So there will be 12 even numbers out of 25. Done. Prime number. When you talk about prime number, we know 2, 3, 5, 7, 11, 13, 17, 19, 23. These are the prime numbers from 1 to 25. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability that you get a prime number is 9 by 25. A multiple of 6. So it has to be 6, 12, 18, 24. So there are 4 numbers out of 25. Done. Okay. Now look at 25. A box contains 15 cards, 15 cards numbered from 1 to 15, which are mixed thoroughly. A card is drawn from the box at random. Find the probability that the number on the card is 1. Odd number. So if you look carefully, 1, 3, 5, 7, 9, 11, 13, 15. So there are how many odd numbers? There are 8 odd numbers. Look, 1, 3, 5, 7, 9, 11, 13, 15. 1, 2, 3, 4, 5, 6, 7, 8. So probability of getting a odd number is 8 by 15. Done. Prime number. If you look carefully, I'll just write it. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What are prime numbers over here? 1, 2, 3, 4, 5, 6 prime numbers are there. So it will be, probability will be 6 by 15, 3 2 times, and 3 5 times. So 2 by 5. Done. Divisible by 3. So 1, 2, 3, 4, 5 numbers are there, which is 3, 6, 9, 12, 15, which are divisible by 3. So the probability will be 5 by 15, that's 1 by 3. Divisible by 3 and 2 both, which indirectly means divisible by 6. So you have 6 and 12. These are the 2 numbers which are divisible by 3 as well as 2. Look carefully. So there are 2 favorable outcomes out of 15. So 2 by 15. Divisible by 3 or 2. Which we can divide either by 2 or 3. So 2, 3, 4, 6, 8, 9, 10, 12, 14, 15. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers out of 15. That's 2 by 3. Done. Perfect square number. 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 1, 2, 3. because 1 ones are 1, 2 twos are 4, 3 threes are 9. Okay, so there are 3 perfect square out of 15. So that's 1 by 5. Done. Pretty easy. Now let us look at the next sum. Now look at sum number 26. A box contains 19 balls bearing number 1, 2, 3, dot, 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 19. A ball is drawn at random from the box. Find the probability that the number is a prime number and divisible by 3 or 5. Neither divisible by 5 nor by 10. An even number. Let's get started. Look, a prime number. So what are the prime numbers over here? 2, 3, 5, 7, 11, 13, 17, 19. 1, 2, 3, 4, 5, 6, 7, 8 prime numbers. So the probability will be 8 by 19. Done. Divisible by 3 or 5. So divisible by 3 is what? 3, 6, 9, 12, 15, 18. Divisible by 5 is 5, 10, 15. I've already done over here. So 1, 2, 3, 4, 5, 6, 7, 8. So the probability will be 8 favorable outcome by 90. 8 by 90. Neither divisible by 5 nor by 10. First of all, how many numbers are divisible by 5 or 10? 5, 10, 15. So apart from these numbers, the rest of the numbers are neither divisible by 5 nor by 10. Which means how many? 19 minus 3. 16 numbers are there. So the probability will be 16 by 19 because there are 16 numbers which are neither divisible by 5 nor by 10. An even number. Now clearly the even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18. So 9 even numbers are there out of 19. Done. Now let us see number 27. Cards marked with numbers 13 to 60 are placed in a box and mixed thoroughly. One card is drawn at random from the box. Find the probability that the number on the card is divisible by 5, a perfect square number. First thing, how many total outcomes are possible? See, 60 minus 13, that's 47, plus 1, 48. So total number of outcomes possible is 48 because from 13 to 60, the total numbers of numbers are 48. That will be the total outcome, which is 48. Divisible by 5, it has to be 15, 20, 25, 30, 35, 40, 45, 50, 55 and 60 also, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers out of 48. That's 2 5s are 2 24s are 5 by 24. A perfect square number. Now from 13 to 60, the perfect square number, the first one will be 4 4s are 16, 25, 5 5s are 25, 6 6 are 36, 7 7s are 49, 8 8s are 64, not possible. So the probability will be 4 by 48, that's 1 by 12. Done. Now let us look at the next sum. Now look at sum number 28. Tickets number 3, 5, 7, 9, odd numbers, starting from 3 till 29 are placed in a box and mixed thoroughly. One ticket is drawn at random from the box. Find the probability that the number on the ticket is a prime number, a number less than 16, a number divisible by 3. First of all, find the sample space C. It will be 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. That's the sample space. The first part. Prime number 3, 5, 7, 11, 13, 17, 19, 23, 29. Is 1, 2, 3, 4, 5, 6, 7, 8, and 9 numbers. So probability will be 9 and the total number of outcome is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's your probability. Now number B. A number less than 16, which means 1, 2, 3, 4, 5, 6, 7. 7 by 14, that's 1 by 2. A number divisible by 3, that is 3, 9, 15, 21, 27. Have I left anything? 3, 7, 15, 21, 27. Yeah, these are the numbers divisible by 3. 1, 2, 3, 4, 5. So probability will be 5 by 14. Done. Now let us look at this side. 29. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number. First of all, your 2-digit number starts from 10, 11, 12 till 90. So how many 2-digit numbers are there? 90 minus 10, that's 80 plus 1, 81 2-digit numbers. So probability will be 81. Favorable outcome. My total outcome is 90. 9 times, 10 times. So 9 by 10. Done. Very easy. A perfect square number from 1 to 90. 1 is a perfect square. 4, 3, 3 is a 9, 16, 25, 36, 49, 64, 81. Isn't it? These are your 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 perfect squares. So probability will be 9 by 90. That's 1 by 10. A number divisible by 5. I think there will be 18 numbers because 5 18s are 90. So there will be 18 numbers which are divisible by 5 out of 90. 9 2 times, 9 10 times. So 2 by 10. Done. Now let us look at the next sum. Look at number 30. Cards marked with numbers 2 to 101 are placed in a box and mixed thoroughly. One card is drawn at random from this box. Find the probability that the number on the card is an even number first of all. First of all, see the numbers are, how many possible outcomes are there? 101 minus 2, that's 99 plus 1. 100 possible outcomes, isn't it? Even number. Yeah, even number will be 2, 4, 6, dot, 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 till 100, which means there will be 50 even numbers. So probability will be number of favorable outcome by total outcome, that's 1 by 2. Done. A number less than 14. So it can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These are your possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So probability that you get a number less than 14 is 12 by 100. 3 times, 425 times. Done. A number which is a perfect square. Again, 1 is not there. 2 2s are 4. So 4. 2 3s are 9. 4 4s are 16. 25, 36, 49, 64, 81, and 100. Yeah. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9 perfect square out of 100. Done. A prime number less than 30. Okay. Starts with 2. So we know the prime number is less than 30. 2, 3, 5, 7, then that's 11, then that's 13, 17, 19, 20, 3, and 29. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there'll be 10 prime numbers out of 100, which is 1 by 10. Done. Clear. Now let us see number 31. A bag contains 15 balls, of which some are white and others are red. If the probability of drawing a red ball is twice that of the white ball, find the number of white balls in the bag. Now, total number of balls for 15. Let the number of white balls be x. Then number of red balls will be 15 minus x. Isn't it? Now, there are First of all, calculate the probability of a red ball. Probability of red ball is 15 minus x by 15, and probability of a white ball, number of white ball is x, so x by 15. Now what the condition has been there, if the probability of drawing a red ball, is twice probability of drawing the white ball, that's x by 15. So just we need to solve it, so that's 15 equals to 3x, x equals to 5, which means how many white balls were there? There were 5 white balls. Clear? Now let us look at the next sum. Now look at 32. A bag contains 6 red balls, and some blue balls. Suppose x number of blue balls. Suppose if the probability of drawing a blue ball is twice that of a red ball, find the number of balls in the bag. Very easy. See, total number of balls, we can write 6 plus x, isn't it? Now, probability of drawing a blue ball will be x by 6 plus x, isn't it? Is twice. This condition is given to us, okay? Probability of blue ball we know, number of blue ball is x, total number of ball is 6 plus x. It's twice probability of red ball is 6 by total number of ball is 6 plus x. Am I correct? So this will give us x equals to 12, which means number of blue ball is 12. And the total number of ball will be 6 plus 12. That's 18 number of balls are there all together in the bag. Done. Now, of course, when you cancel this, x not equal to minus 6. Because when you put x equals to minus 6, this becomes 0. Something by 0 is undefined. Now, a bag contains 24 balls, of which x are red, 2x are white, and 3x are blue. So, can I say x plus 2x plus 3x equals to 24? Because x are red ball, isn't it? 2x are white ball, and 3x are blue ball. A ball is selected at random. Find the probability that it is white, not red. First of all, find the number of red, white, and blue ball. This is 3 plus 2, 5, 6x. 6x equals to 24, x equals to 4. Which means the number of red ball, when you're talking about red ball, is 4. White ball, 4 2s are 8. And blue ball, 4 3s are 12. Now, probability of white ball will be 8 by 24, that's 1 by 3. Probability of not red, which means either white or blue, that's 8 plus 12. 20 favorable outcomes out of 24 for 5 times, for 6 times. Done. Or you can do like 4 by 24, probability of red, then 1 minus 4 by 24. That also you can do. 1 minus 4 by 24. This is for red, and not red will be 1 minus 4 by 24. That comes the same thing. Okay. Now let us look at the next sum. Look at 34. Very interesting. A card is drawn from a well shuffled pack of 52 cards. Find the probability of getting. There are 12 parts. Just a recap of cards. We know there are 52 cards in all, and there are 4 different suits. 13 hearts, which is red in color, 13 diamond, 13 spades, and 13 club. So they add to give 52 cards. Now, when you talk about a particular suit, there is a king, a queen, a jack, an ace, and then there are numbered cards, which is 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 9, 10, 11, 12, 13 cards all together. Same goes for diamond, spades, and club. Now look, they are asking 2 of spades. So there will be one particular card, 2 of spades out of 52 cards. So it will be 1 by 52. One favorable outcome out of 52. A jack. Now look, there will be 1, 2, 3, 4 jack. Isn't it? In each suit there is a jack. So that's 4 by 52, that's 1 by 13. Done. A king of red color, so there will be two kings of red color, either king of heart or king of diamond, so that's 2 by 52, that's 1 by 26. A card of diamond, there are 13 cards of diamond out of 52, that's 1 by 4. A king or a queen, there are 4 kings and 4 queen, that's 8 by 52. 4 2 times 4, 13 times 2 by 15. Clear? A non-face card. Now look carefully. These 3 are known as the face card. So the rest 10 cards are non-face card. So 10, 20, 30, 40 cards are non-face card out of 52. 4 10 times, 4 13 times. Then a black face card, which means 3 of spades and 3 of clubs. So that 6 by 52, 2 3 times, 2 26 times. Clear? A black card, so there will be 26 black cards out of 52, that's 1 by 2. A non-ace card, now there are 4 ace cards, so remove that, whatever is left is a non-ace card, which means 49, sorry, 4 remove, 52, 48 non-face card out of 52. Just remember, ace card means what? There will be 4 ace cards. Total is 52. So other 52 minus 4, that's 48 are non-ace card. 48 by 52, 4 12 times, 4 13 times. Non-face card of black color. So black color, there are 6 face card, 3 over here and 3 over here. So the rest 20 a non-face card of black color. So it will be 20 by 52 for 5 times, for 13 times. Am I clear? Neither a spade nor a jack, which means you remove all the 13 cards from here, spades remove, nor a jack, 1 2 3, 1 card from here, 1 card from here, 1 card from here, 13 14 15 16 cards are removed. The rest can come. So 52 minus 16, see, 13 spades removed, 1 from each removed, so that's 6, 36 out of 52, 4 9 times, 4 13 times. So that's the probability that you get neither a spade nor a jack, neither a heart nor a red king. See, heart, which means all 13 removed and 1 diamond removed because a red card they've sold. 14 cards removed out of 52. So 52 minus 14. The rest can appear. So 12 minus 4 is 8. 38. So that's 38 by 52. Okay, that's 219 times, 226 times. Done. Very interesting. You should know how many cards are there. Okay, what are the different types of card? Okay, now look at the next sum. Now look at sum number 35. All the 3 face card of spades are removed from a well shuffled pack of 52 cards. A card is then drawn at random from the remaining pack. Find the probability that the card drawn is. So many things they have told us to find. First of all, see, from spade 3 cards are removed, which means 10 remains. That also face cards are removed. Face cards are removed from here. There are 3 face cards, king, queen and jack. Black color, okay. Now what they're asking, a black face card. So out of 52, 3 card goes away, which means 49 card remains. Now there are 3 face card over here. Am I correct or not? Which means probability of getting a black face card, 3 from this set, okay. So 3 by 49. Done. Because the total number of outcome is 49. A queen. Now look, you can get a queen from here and from here. Because the queen from here is removed. Spades is removed, okay. So you can get 3 queen out of 49. Isn't it? A black card now. 13 over here and 10 over here. So 23 out of 49. Am I clear? A heart, 13 heart out of 49 cards. A spade. Now 3 are removed, which means 10 are spades. So 10 by 49. Am I correct? 9 of black color. Now you can get a black color 9 from here and from here, which means 2 out of 49. Done. Now let us look at the next sum. Now look at number 36. From a pack of 52 cards, a black jack, a red queen and 2 black king fell down. Assume that a black jack from here, jack fell down. So we are subtracting jack. A red queen, suppose a red queen from here, from this, red queen fell down, okay, and 2 black kings, means a king from here and a king from here fell down. So out of 52 cards, 1, 2, 3, 4 cards fell down. So 52 minus 4, that's 48 card remains. Okay, you can, if somebody is taking that a queen fell from diamonds, then also that is correct. I have taken that the queen of heart fell down. Okay, now what they say, a card was then drawn from the remaining pack. Find the probability that the card drawn is a black card. Now see, 3 black cards are removed out of 26. So the probability that it is black is 26 minus 3. That's 23 by 48. Isn't it? Now, yeah, a king. Now, 1, 2, 2 kings are there in the pack of 48 cards, because these 2 kings have already fallen down. So it will be 2 by 48, that's 1 by 24. A red queen, 1 red queen is there, 1 has fallen down. So probability will be 1 by 48. Pretty easy, okay? Now let us look at the next sum. Now look at this one, number 37. 2 coins are tossed once. Find the probability of getting 2 heads, at least 1 tail. First find the sample space. When 2 coins are tossed together, head, head, tail, tail, head, tail, tail, head. These are your 4 possible outcomes. 2 heads. So probability of getting 2 heads will be 1 by 4. At least 1 tail, which means this one, and this one. There has to be 1 tail at least. Okay, so it will be 3 by 4. Done. Now, next one, 38. 2 different coins are tossed simultaneously. Find the probability of getting 2 tails. Same case. 2 tails, that is 1 by 4 probability. 1 tail, which means this one and this one. ST and TH, which means 2 out of 4, that is 1 by 2. Am I clear? No tail, which means in both it should be head head, which is 1 by, no tail, which means 1 by 4. The last one, at most 1 tail, which means maximum 1 tail. So this qualifies, this one and this one. Even if there is no tail, that will also be considered as our outcome, which means 3 out of 4 outcomes. Done. See, at most 1 tail means HH, HT, TH. Remember this. Okay. Now let us look at the next sum. Now look at sum number 39, the last sum from this exercise. 2 different dice are thrown at the same time. Find the probability of getting a doublet, a sum of 8, sum divisible by 5, a sum of at least 11. First of all, Get the sample space. See. And just draw. Look carefully. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm getting the outcome. For the first die, 1, 2, 3, 4, 5, 6 can come. For the second die, 1, 2, 3, 4, 5, 6 can come. So 1 can come. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. It may happen that on the first die you have 1, on the second die you have 1, on the first die you have 1, on the second die you have 2, like this. Now on the first die you have 2, on the second die you have 1. So 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now there are altogether 36 outcomes, if you can see. Okay. Now see what they're asking. A doublet. Doublet means on both the faces you have the same numbers, which means 6 outcome, favorable outcome out of 36. That's 1 by 6. A sum of 8, which means when you add, you should get 8, which means look over here. 2, 6 qualifies. 3, 5 qualifies. 4, 4 qualifies. 5, 3 qualifies. 6, 2 qualifies. Anything else? A sum of 8. Not in this line. 6 plus 2, 8. Yeah. 5 plus 3, 8. Yeah. 4 plus 4, 8. 5 plus 3, 8. 6 plus 2, 8. So how many? 1, 2, 3, 4, 5. So 5 out of 36. Done. Sum divisible by 5, which means when you add them, it should be a multiple of 5, which means 5, 10, 15, like this. So see, the cases where you add and you get 5 or 10. 4, 1. 2, 3. Anything else in this 4? No. This one? No. Yeah. Then 3, 2, 4, 1, 5, 1. No, 5, 1 will not be there because 5 plus 1 is 6. Over here 5, 5 will be there. Look carefully. And over here 6, 4 will be there. Look carefully. 6 plus 4 is 10. Divisible by 5. 5 plus 5 is 10. Divisible by 5. Then over here 4 plus 1 gives you 5. Divisible by 5. Which is 6 plus 4 also is here. 6 plus 4 is 10. Again divisible by 5. 3 plus 2, 5. It is divisible by 5. 2 plus 3, 5. Divisible by 5. 1 plus 4 is 5. So how many? 1, 2, 3, 4, 5, 6, 7 numbers. So probability will be 7 by 36. Done. Now sum of at least 11, which means when you add them, you should get 11 or more than 11. 3 cases only. 6, 5, 6, 6, 5, 6. See? 5, 6, 6, 5 and 6, 6. Because in all those cases, if you add, you get 11 or more than 11. Isn't it? So there are 3 out of 36, which is 1 by 3. Done. So keep it till here in this video. In the next video, we'll see some other chapter. Till then, take care. And if you like the video, do subscribe